Hello and welcome to the Chandara Academy. In today's video, we are going to find out and discover the cotangent function, which is the inverse of the tangent function. Okay, so the cotangent function, so here is a cotan, is defined on decotan, an interval inside of R, or reunion of interval that we will need to identify in the first question. Its expression is equal to cosinus of x over sinus of x. And in the second question, we are going to prove some relation. Okay, so first question. What is the domain of definition decotan of the cotangent? So, in other words, what are the points where something goes wrong? So, cosinus is defined on R, so all real numbers. Sinus is defined on all real numbers, okay? But what do we have here? We have a division, and we do not want absolutely to divide by 0. So we don't want x. We don't want x, such as sinus for all x, such as sinus of x, is different from 0. If we take the trigonometric circle, let's write it down. We've got sinus is equal to 0 in this point. Okay, so 0. If I add pi, okay, I go to pi, and this is still equal to 0. If I add pi again, I go to 2 pi, and this is still equal to 0, 3 pi, etc. I can do it backward. 0 to minus pi, we still have sinus equal to 0. Minus 2 pi, same thing. And minus 2019 pi, this will be exactly the same thing. So how to write this down in terms of mathematics? We can say that this is for all x, such as x can be written as k times pi, with k a relative number, so every multiples of k. This can be 1 times pi, 2013 times pi, minus 19 times pi, as long as what's in front is a relative number. This is right. So now we don't want those x's. So how to write down the domain of definition of cotan is equal to all the values possible of x, so R, without, so the backslash is here to say without, all the x's in R, such as, so this is, we read it like that, such as x is equal to k times pi, with k a relative number. And this is the right answer. So maybe we don't want you in high school to write things exactly like that. But we can ask you the question, for what x's between 0 and 2 pi does cotan of x exist? And here you will say, so 0 pi excluded, because these are multiples of pi, reunion with pi, 2 pi. Okay, but this is the general interval of definition of cotan. Perfect. So now, for the second question, we want to prove that for all x's in the domain of cotan, we've got cotan squared of x, which is equal to 1 over sinus squared of x minus 1. Okay, and why does this inequation make sense? Because for all x in d of cotan, you've got this that is different from 0. Okay, so now just a little bit of work. Let's write down cotan squared of x is equal to the definition cosinus squared of x over sinus squared of x. Here in the equation we don't have any cosinus left, so let's get rid of the cosinus. We've got cosinus squared of x, which is equal to easily 1 minus sinus squared of x. So this is very fundamental. Let's apply this to our equation. We've got cotangent squared of x, which is equal to 1 minus sinus squared of x over sinus squared of x. With a little bit of simplification, we've got cotangent squared of x, which is equal to 1 over sine squared of x, minus 1 for all x, of course, in the domain of cotangent. And we have solved our second question. And with that, we've solved the whole exercise. Hope you enjoyed the video. See you soon. Bye.